Hello, everyone. Thank you for joining early. Just doing some sound checks, and we'll be getting started right away. In the meantime, enjoy the beats. What can I do? What can I say? So many times I try to find what I'm really feeling like. All these days just running through my mind. It's nice just to stay on the floor. Here at home. Alrighty, it is time to get started. So I know people flow in over time, so maybe we can get a few more moments to do intros. But we have today Jazzy and Zellic, not gonna dox, but yeah, I think I see you requested add a speaker. Okay, now cool. So we have Jazzy and Zellic on. Excited to have you on, talk about smart contract security. A lot of hacks happened the last few years, even the last few months. Excited to get your perspectives and also hear your thoughts on Move. Really great to be working with y'all, and yeah, happy to be here.
Yeah. Thank you for inviting me. And yeah, it is also a pleasure to work with you all. So as an introduction, I'm Jazzy, and I'm the co-founder of Zellic. We have been doing blockchain security for about the past year and a half now. And I have my partner, Steven, with me. Wait, Steven is not a speaker yet. Does he have permission? Wait, Zellic just left.
Yeah, just adding him up again. There we go. I see him as speaker connecting. Awesome.
Hey, hello. Hey, it's me, Steven. What's up?
Awesome. Yeah, thank you for being on board here. We'd like to get a bit of an intro for our audience here. Maybe tell us a little bit about yourself. how you came to work on Zellic, and yeah, I'm sure the audience here would love to know.
Sure. So I met Jazzy about 5 years ago when we were in high school. We were playing these hacking competitions called CTFs. If you don't know what a CTF is, you can think of it as like a math competition, but instead of solving math problems, you have to hack software. So when we were in high school, we started playing these CTFs together, and we formed a team called Perfect Blue. That team went on to become the #1 team in the entire world over the course of 2020 and 2021. And then we decided around then that we should start doing smart contract audits. My friend Sam Zizi's son, we were friends for a long time. He told me that we should go do audits and that there's this huge issue where people are paying a lot of money for these very, very low quality audits. And we decided that after we read a bunch of these audit reports, we were really unhappy with the state of the industry. We thought that we could do better. We thought that we could provide a useful service for the community. And that's why we started working on Zellic. And it's really grown since we started it as just a 2-person shop. I think we're almost 20 people now. And very proud of all the work that we've done, all the projects that we've secured. And yeah, me and Jazzy, we've been in crypto for quite a long time. I think we've both been in it since around 2016. Granted, we've seen everything from the ICO and, ICO bubble in 2017 all the way up to what we see now. So yeah, Pontem, please go ahead.
Yeah, that's pretty crazy. I didn't know they had like Hacker Olympics. Would love to kind of like dive deeper into that. How did you get involved in that, and what was that like going through all these competitions and then becoming the #1 team?
Well, it's actually kind of a bummer because in 2020 in 2021 we were supposed to go to all these like competitions across the world. So actually when we were playing back then, we were college students and we were essentially just competing for free travel, because if you like qualify for the finals, you can usually like go to the finals in some like place in the world where there might be like Korea or Japan or like Romania, and they'll usually like pay for your flights. But it was right during COVID that we got really good, so we didn't get to go to as many as we hoped to. But we did get to go to quite a few places, and now that COVID's over, me and Jazzy, we still play for fun on the weekends when we have time on the weekends, right? Because running a company is like a lot of work. But yeah, it's really sweet. And just in general, great community, lots of really smart people, thoughtful people, and you get to solve really interesting challenges. And it keeps you sharp on the tech side too.
Nice. What does that actually look like? Is it like predefined puzzles, or maybe like is it you go up against other teams and trying to hack each other?
Oh yeah, great question. So there's multiple formats in these CTFs. So oftentimes the most common format is like a Jeopardy format, which is, as you described, is just some predefined puzzles. And if you solve them, you get points. There's like a leaderboard for how many points you have. Usually it's like a 36, 24, or 48-hour competition. There's also attack defense CTFs, which are very high touch. They're quite complicated to set up, and because of that, you don't see AD CTFs that often. But some of the more prestigious CTFs like DEF CON CTF, which we participated in last year and the year before that, they're also attack defense. And that one is like you have a bunch of teams on the same network are trying to hack each other. You have some like vulnerable services that you have to host, and you have to patch your own services to fill all the holes, fix all the bugs, and you also have to exploit those same bugs to attack other people's instances of those services. It's pretty sweet.
Yeah, that seems.
It is very fun.
Yeah, it's like Nerd Olympic, but like super simple because you end up using.
Yeah, yeah.
Is there any boundaries? Like, is social engineering and other, I guess, other tactics?
Oh, we actually got busted last year because I ran like a fork bomb on one of the competitors' servers, and apparently that's not kosher.
Yeah, I mean, if you're a hacker, there's really no rules or boundaries. So in my opinion, doesn't make sense to put boundaries on a hacking competition. But that's,
well, I mean, like you wouldn't want to like blackmail your competitors, right?
That's true. That's true. Yeah, you probably don't want to ransomware and ask for Bitcoin to continue the competition.
Yeah.
Awesome. So from that, what really got you interested into crypto? What was your journey into it? And
Jazzy, you want to explain your story? Because I think our stories are pretty similar.
Yeah, I mean, so my story is like, so I first got introduced to crypto back in 2015 when I was still back in India. So I was like this 15-year-old kid in India, and I was doing some freelance work. And the best way for me to get paid was Bitcoin. And I'm like, this is very cool. And then right when I moved to Canada around 2016, I heard about Ethereum, and it was just like very interesting because it was a concept where you could write code on the blockchain and it would run on every single computer around the world. So I just got super interested into that. I started looking into Geth VM. I think I found a bug in the Geth VM itself around 2018, 2019. And late 2020, I started doing a lot of MEV, and which was also very fun. And yeah, I mean, most of my interest was just like my own curiosity of like blockchains just seem very cool, and we just got deeper and deeper into it.
Oh, nice.
Yeah.
You said that you found a bug in like Geth, the Go Ethereum implementation.
Yep.
Oh wow, that's crazy. Yeah, definitely have some follow-up questions there. Yeah, sorry, go ahead, Steven.
I guess if you want to know more about how I got into it, it's very similar. I was like a 16-year-old kid, and I wanted to do some freelance work on the internet. And yeah, I got paid through Bitcoin. I'm like, oh, this is lit. And also because I had a lot of internet friends at the time, it's kind of hard to send your friends money if they live across an ocean from you because banks are annoying when it comes to that, especially if you're all like 16-year-old kids. So yeah, we used to like remit money and accept money through with cryptocurrencies, and that's I got into it, and then I discovered there's such a thing as pay to script hash on Bitcoin. I was like, okay, so Ethereum took the idea, made it turn complete, made a more rich set of opcodes, and then that's how I got into all this stuff.
Nice. That's definitely encouraging to hear that it was through an actual use case, being able to take potentially cross-border payments. Yeah, I'm actually super curious to hear, Jazzy, I guess even following up on what we said earlier. It seems like you have really intimate knowledge with the EVM. Kind of curious to hear your thoughts how the Move VM compares. I know that from overall narrative perspective, people say that the Move is safer than Solidity. So yeah, I want to hear it from experts like yourself. What do you think?
Yeah, I mean, so if you look at like the VM level, so I would definitely say like there are less ways to like basically do wrong things in moves, whereas I mean, so you can think of EVM as like a thing where everything is allowed, and there's a lot of ways you can fuck up things and things can go wrong. Whereas MoveVM is designed in a way that it is harder to like have things go wrong. So I think, for example, having linear types and having the whole like, I mean, basically having a type system at the VM level really protects you from like a lot of issues that are plaguing EVM. For example, there's no reentrancy on the move side because you need to know all the addresses at compile time, which really reduces the attack surface. And also the capability attack. I mean, and also the capability pattern of like basically having like the least privilege access level is also super useful as people have been using on the Move VM side. So I think Move VM is definitely like a bit more safer, but it also comes at the cost of composability because since you need to know everything at the compile time, you can't really compose arbitrary contracts on at the Move VM level. But yeah.
I think that's a very good summary.
Yeah, so as I understand it, there's some ways that just makes it easier for developers to not make maybe common mistakes. But there are probably still a lot of best practices that need to be followed, just in general for smart contract building that still apply to Move. I guess out of the ones that you mentioned, which do you think causes maybe the most amount of hacks on Ethereum that potentially we won't see as frequently happen on Move?
Reentrancy?
Yeah, yeah, like so if you look at like the history of Ethereum, there were a lot of issues that happened due to reentrancy, but like reentrancy has slowed down in the recent years, just because people like to slap reentrancy dot on every single contract now, which has reduced the bug. But yeah, I mean, reentrancy would be one. Back before Solidity 0.8, there was integer underflows and overflows, which move VM stops at the VM level. But before Solidity 0.8, everything could underflow and overflow. which definitely caused a lot of issues on Ethereum side, which I don't think is possible on Move VM either.
I think
Apart from that,
I think when we say like underflow and overflow, it's a bit. I think the better way to think of overflow and underflow is like sending negative money to someone. That's like a funny outcome of underflow and overflow. But yeah, Jazzy, go on.
yeah, yeah. I mean, I don't think there's much. I mean, so apart from that, I mean, most of the bugs that we find on audits these days are usually business logic bugs, which affect both EVM and Move at the same level, because business logic you essentially can't solve that at the code level, because business logic is like, my thing is supposed to do this, this, and this, and it's doing this, this, and this. But is that actually what you intended to do?
Yeah, and that's business logic hacks can affect any smart contract really. Do you feel like Move, maybe because it's a little bit easier to read, maybe compared to like Rust, building with Rust on Solana, maybe makes it more intuitive or easier to audit, or easier to look for these business logic errors?
I mean, definitely having high readability helps. Plus, since there's formal verification directly built into Move, so if you know your spec well, and your spec is um, concise enough that you can prove it, then you can solve a lot of like logic issues that way. That if you know your logic is like correct, but there are a lot of issues where people believe that the logic is correct, but like it's typically not, because they have not considered like all the consequences of like certain type of logic, or like yeah.
Yeah, or maybe all edge cases. Yeah. Um, so the prover is also something that's touted as a feature of Move that people really like. I definitely understand that for Solidity, there's also provers, but yeah, would love to hear from you what the differences are or similarities between what's available with Move with the prover, and how you have to do proving on Solidity.
Well, the provers on Solidity, you're probably talking about the SMT checker, right?
I believe so. Yeah.
Well, the SMT checker is fairly simple. It's basically like either a bounded model checker or a constraint horn clause solver. They basically just reinterpret the Solidity code. You can think of it almost as line by line into a series of SMT formulas, and then it plugs these into SMT solver like Z3 or CVC5, or actually no, it uses CVC4. Then the Move prover, I believe it's also based on like an SMT approach. However, it's a bit more crafty with how it uses SMT. For example, it also finds loop pre and post conditions, and it also finds loop invariants, right? If I remember what I learned from the slides correctly. I remember talking to Meng, who was on the DM team at the time, and he had some really interesting things to say. I think the Move prover is definitely a lot more powerful than the SMT checker currently, and that's just because it's integrated into the language at a much deeper level. It also applies some of the things that we've learned in academia about formal verification that I don't think have been really ported to SMT checker yet.
Very cool. And how do you see that maybe scaling? Is it relatively easy for teams to do formal verification on their code, or is there some form of libraries or something that can be reused? Like, do you see this formal verification for Move being widely adopted, and if not, what are some of the challenges?
Well, formal verification is tricky for two reasons. The first one is actually getting your code to verify. It could be that it's very hard to convince the prover that your code matches the spec, and that could be because your spec is something complicated or requires some inductive property. For example, regardless of whether you're using the Move prover or the Solidity SMT checker, I think that you would be hard pressed to prove that a square root function that uses like Newton's method uh, converges, because that proof requires like actual math and calculus. At the same time, I imagine it would be challenging to prove properties about data structures, because those are also inductive proofs, right? In general, I think approaches like the Move prover and SMT checker, they don't do well with inductive properties. I also think that the second issue would be, when you're doing formal verification, is you don't have bugs in your code anymore, sure, but then you might have bugs in your specification. You may forget to rule out certain edge cases in your spec. or considering them altogether. I think these are two common issues that we see everywhere when it comes to formal verification from both hardware circuitry and software. In general, in terms of how the industry is going to proceed with its relationship with formal verification, I think that we're probably going to see the rise of formally verified libraries that become almost standard libraries for the community. For example, this would be like the Open Zeppelin stuff back in the EVM world. Granted, I'm not sure if those are formally verified, but I think that we'll see the rise of a set of formally verified libraries that everyone builds using as primitives.
Yeah, that's a really good point, and I know we've wanted to do some form of verification on some of the math for Liquidswap, and open sourcing that would definitely be useful for the community. One one building block that we need potentially is something like an Open Zeppelin, like a big library of reusable code. Maybe the standard libraries, I guess, for the framework could be that, but potentially there's still a lot of pieces missing. But yeah, kind of curious to hear your view, I guess, maybe even outside of just security, what you think of Move compared to some of the other languages. I guess Solidity is the biggest one, but if you're familiar with others, just honest thoughts.
It's an incredibly well-designed language. It was designed very thoughtfully and carefully by a team of extremely smart people. I know this because I used to be colleagues with Meng Su, who was on the DM team. That was back when I was in university. I was an undergrad. I was in a research lab, and Meng was one of my colleagues at the research lab. If you look through some of the slides or just the papers for Move, it's designed incredibly well. It knows exactly what it's trying to do. The use case is very clearly, we want to write some secure smart contracts. We want to make it as difficult as possible to shoot yourself in the foot or make it even impossible to do that. I think that compared to Solidity, which definitely feels like it was, was developed organically and a lot of features are ad hoc, I think that Move is very careful in what facilities it makes available to the developers, and that's a good thing. I also believe that the linear type system is just like, one of those new age, okay, linear type systems have been around for like decades, but the resurgence is definitely like a Zoomer thing, and I also think that it's a good thing.
By Zoomer, you mean Gen Z? Like
Yeah.
where it's kind of like bringing back something that used to be old school, cool.
Yeah.
Zoomer thing.
Awesome. Yeah, any thoughts there, Jazzy, on Move versus other languages?
And I mean, so I would say like my thoughts are very similar to Steven, that like Move just makes it like incredibly hard to like shoot yourself in the foot. Like in the case of Solidity, there's just a lot of ways you can do something in the wrong way. In Move, there's not a lot of ways you can do something. So there's only like a very select ways to like do a certain operation. So like it just constrains you in a way that it makes you do the things in the right way, which I think is very useful, especially for like critical applications like blockchain. Like, I mean, if you look at the history of Move, Move was designed to be ran only on blockchains or like mainly on blockchains. So like all of its design and planning has been focused exactly on like blockchains and like also formal verification, because formal verification was a first class use case for Move as it was being designed. So it is like easier to formally verify Move as compared to Solidity just because of the design principles of Move.
I mean, I also think that Move just like feels better to write. Like in Solidity, I always have to like fucking try 3 or 4 times to like cast a UN32 to an address. You have to like go first to UN256 and then cast that to. It's like dumb.
Yeah, I mean it's
Or it's like, have you ever tried to like do like UN256 of like -1, like in Solidity, just like Solidity 0.8? Like I just like type in 0xffff every time now because it's just like I can't remember the right syntax to do it because I don't know, Solidity is just designed in like it's like a mishmash of stuff. It's like it feels like designed by committee,
yeah. I
basically.
think Gavin from Polkadot was the person behind it, and it's a noble first attempt. Like this was Ethereum was definitely groundbreaking for the time.
Oh yeah, yeah.
100%.
Like Solidity needs to have existed so that like we can build off of it. But it does feel like I'm writing JavaScript sometimes, and it just does not inspire confidence when it feels like I'm writing JavaScript that's going to be like handling tens or hundreds of millions of
Yeah,
dollars.
Yeah, like I mean, you can think of it like JavaScript, but on the blockchain.
yeah, it's kind of
Yeah.
like I doubt some of the banking systems or like critical infrastructure of the apps that we use run on JavaScript, right? Like they're probably,
Oh, I mean, no, they run on COBOL.
yeah, it's COBOL, like a low level language.
No, like COBOL is like a mainframe shit.
Yeah, exactly.
It was like ancient
And I
mainframe
guess similar
language.
here, you're also very close to the I guess to the servers or the hardware, right? Like you need something that's super close to like it doesn't need to be that abstracted away, perhaps.
Oh, I don't know about that. I mean, I think there's upsides and downsides to abstraction or not having
Right, because you still
abstraction.
need to build all these applications. It's kind of yeah, it gets blockchain's kind of weird because the what you're building or the logic that you're building is so close to the hardware, but it's also like, the applications themselves need to be relatively intuitive for people to build this complex business logic. Otherwise, it can be very, very hard.
Yeah. Hey, Pontem, what are your plans for 2023?
Yeah, for 2023, we're excited about working on concentrated liquidity. We think we can speed run Uniswap on some major features that I think the whole industry is researching and moving towards. One of them is volatile fees, essentially based on internal volatility. Oracle have dynamic fees that can help reduce some of the impermanent loss. We're also looking at things like discretized liquidity for liquidity provisioning, which should help with price slippage within certain steps of pricing. We're also working towards. I talked about this at another one. We haven't made a formal announcement, but we're really bullish on Move, and we want to make sure that it's available on Ethereum. Myself, I'm definitely a believer in Aptos and high throughput chains. I think Ethereum currently, even layer twos are going to have scalability issues, like the latency for something to have finality on Ethereum will still take several minutes, potentially like up to an hour, depending on how many confirmations. And even the throughput, we're still at like a few hundred, maybe a few thousand. And even if all the bandwidth was taken up by an L2, we're still pretty far away from like tens of thousands, maybe hundreds of thousands on Ethereum. But the bandwidth is not being used yet, and most of the maybe Lindy effect of store of value and what people are speculating on is on ETH and maybe wrap Bitcoin on ETH and perpetuals for doing speculation on future prices. So we're seeing a lot of that, for example, on Arbitrum with GMX, DYDX, but even though that's on Cosmos. So our goal is to essentially deploy the Move VM on Ethereum so that application developers on Ethereum have the same optionality that they do with Solidity as they do with Move to deploy on various chains. So currently it would be Aptos, then Ethereum, but this model is expandable to more chains, but it really would depend by each ecosystem. Like for example, on Avalanche, it might have to be its own subnet, which comes with its own uh, intricacies, and similar with Cosmos versus something like, for example, ZK Zinc, which uses the LLVM, which is a compiler commonly used for their ZK EVM implementation, is relatively doable to do something similar with Move. So yeah, bringing Move to Ethereum, I think, is going to be a huge milestone for the industry, and yeah, we're excited to work on making that happen. So that's probably the biggest development that we're going to be working towards in 2023.
Awesome. Yeah. Uh, okay. That's really exciting.
Yeah, I think the biggest challenge, and would love to hear your thoughts on it too, is like compatibility with EVM. Like as I best understand it, even if you're like all these different runtimes might still need to be run asynchronously. So you might break composability across them unless you have like two runtimes and like sorry, two VMs in the runtime, I guess. Um, but there, at least as I look at Neon, for example, on Solana, it does look like they're working on ways to not break composability between the EVM and the, I guess, Solana VM that they have. So I think that might be one of the biggest challenges. Like, are we creating like these kind of like bubbles of applications that can't compose with ones that are with other that are operating on other VMs. So yeah, kind of curious to hear your thoughts on that and what some of the challenges might be, and even potentially how they could be solved.
Yeah, and so I think the easiest way might be to have multiple VMs because that just makes things like more coherent. But like, I don't think anyone will go towards that just because it makes the blockchain significantly more complicated when you have multiple execution layers. So the the solution that Neon is taking, where they're building a EVM on top of the BPF interpreter, is probably pretty okay. But like, again, as you said, like it breaks composability because you have to break a single transaction into like multiple asynchronous transactions, and that just reduces the overall composability of the platform because you can't really get the result of your execution in the same transaction. But yeah, I mean, so I don't know what's the best way to go about fixing that though, because that just seems like a challenge at the execution level. Like, unless you're able to execute the whole maybe it is possible to have like a layer 2 with a different execution layer. Maybe you can make a layer 2, which is, and actually, no, never mind. That might not work either. Steven, what are your thoughts?
On how to get like multiple
Move,
execution layers?
yeah, move on EVM or vice versa. Hmm.
I'm thinking, well, it depends on how much you want to compromise in the move language.
Mm-hmm.
Because I think like if you just like didn't do any of like the checks that the move VM does, you could totally just like port the language over and have it write a backend that compiles to like EVM bytecode. But if you
Uh,
want to have all the checks, you probably need to write some built-ins to do that, right?
you can definitely have a compiler that like compiles the equivalent version to EVM, but it won't really have like all the runtime or the bytecode verification checks.
Oh yeah. I mean, technically you could do that because it is like Turing complete. You could just run that like on the chain. It'll just be like really stupid, like
Yeah.
incredibly inefficient.
Yeah, it seems like the layer on top might be a good way. What we're researching is this, I guess, L3 architecture that ZK enables, where you can have what seems like app chains essentially connecting to kind of like a public chain that then checkpoints into Ethereum, and then these individual app chains can have even like their own
Mhm.
consensus. Although you still break, like if this one is just move runtime, for example, you would still not have the EVM composability. So like any calls to Solidity contracts would be asynchronous. Um, I think actually, I mean the main issue there is probably just going to be MEV. Like if there's any arbitrage between, let's say like an Aave running on another app chain, I guess, and Liquidswap, then or another credit protocol potentially like arbitraging on yields. You would have MEV between the two if it's asynchronous. I think Cosmos is working on like some form, maybe like a sequencer or some form of intermediary between their different app chains, so that transactions can get executed, I guess, atomically or at once. So that could potentially be a solution. But I think, yeah, it's going to be hard to figure out how to actually have, yeah, atomicity or having these contract calls between different runtimes execute. That's definitely one of the biggest challenges.
Mm-hmm. Yeah, it also brings up the point on like how much do you want atomicity? Like, there's a lot of applications that depend on atomicity, but like as applications grow bigger, there might be less need for it.
Yeah,
What do you mean by that?
Uh, uh, so I'm just thinking about, for example, Near, right? Near as at its core is not atomic when you do cross-contract calls, and there's still like relatively okay applications built on it because you can program against atomicity by having like state freezes that when you do a asynchronous call, you can just freeze your state and you accept nothing else.
Oh yeah, but
Like
like it just makes like development
it just
life like
it
a lot more
it, it,
work.
it just makes a lot more work, but like it's doable. It's just like you have to program around the you just have to program around the non-existence of atomicity.
Yeah, but also like makes like your code not source code compatible, right? Because if on one implementation you have atomicity and the other one you don't, that means that when you port it over, you can't just use the same code base. You have to like basically rewrite it. It's like, then what's
If
the
def,
point?
if defs,
Buddy, I thought we learned
if
a
def,
lesson about. I thought we learned a lesson about this.
if defs are on the blockchain.
Oh my god, brother, Jazzy, you can't propose bad language ideas just because it'll make people write more bugs and create more jobs for us. Think about it. Like that's not fair, Jazzy.
Is that not the long? Okay, never mind.
Jazzy, you're in a public Twitter space right now. Think about what you
Uh,
say before you say
Yep.
it, Jazzy. I know you're the one who usually says that to me, but come on,
Yeah.
man.
I was joking, but yeah.
Yeah, I mean, by the way, if it's not obvious, we're joking.
Yeah,
It's
we
like
need
a
to
bit.
move towards just having completely perfect contracts written by ChatGPT, and then everything will be okay.
Oh yeah, 100%, 100%.
Oh,
Yeah, no, why write contracts when you can just make it write bytecode directly and only ChatGPT can read it?
okay, so pulling on this thread a little bit more, I'm kind of curious to hear maybe your vision for what blockchain looks like in 5-10 years. Is it a bunch of islands that have this asynchronous problem where it's just like these islands, or maybe like nation states on the internet, on the metaverse, kind of like connecting and composing and working really well together, and then every once in a while, someone needs to do something, another nation state, and there's like some cross messaging protocol that does it asynchronously? Or do you think we could get to a maybe like a holy grail of atomicity or synchronous state between all these different blockchains? Just kind of curious to hear where you think and what this looks like.
Oh, I have no idea.
Yeah, uh, I don't think we can really predict this, but like, on a multi-chain future, it does look possible where you have like different layer ones, just like with their own different intricacies, and there's a cross-chain protocol. That is one possibility, but like, I'm not sure because the blockchain ecosystem just like develops so fast that there is not really a way you can predict any of this.
Yeah, I mean, like 10 years ago, could you have predicted that we would be where we are now? Because 10 years ago, we didn't even have Ethereum.
Yeah, that's right. That was
Yeah,
2014, right? Ethereum.
yeah, Ethereum
2015,
came out.
wasn't it?
They had their
Their
ICO.
ICO in 2014, yeah.
Yeah,
Yeah.
it feels like a trope to say we're early, maybe because there's been so much like price volatility and the quote unquote market cap is so high, but the tech itself doesn't really work yet at what we think it should work for us to actually sustain like billions of people. So it's definitely early, I guess.
Yeah, very much so. Like,
Do you think we'll ever get there? Like,
yeah.
is because even 100,000 TPS, right? Like that doesn't sound enough to run like a Twitter or a Facebook. Or even like Visa, I guess that's like 600K TPS. So how are we going to put everything on the blockchain?
I mean, I think that the question is a bit. I think like, how are we going to know what the final use case is going to even be, right? Because there could be use cases that are unlocked by blockchain that we don't even know about yet. I think it could be a mistake to assume that we have to, because it could, be thinking inside the box to think like, oh, it has to be Facebook on a blockchain, right? Who knows? There could be some new use case that was completely not possible before. Like, for example, like, who would have predicted the rise of DeFi when Ethereum just came out, right? Well, other than Vitalik,
Yeah.
but yeah.
I think we'll probably see some maturation of the existing use cases that have. So okay, this is controversial to say, but I think at least short to middle term, really the only use cases that apply are store of value. So we're seeing Bitcoin. I think NFTs fall under this as well, where people are storing value in art or some commemorative object. And then ETH, I think, as a coin, is also earning store value. And then there's trading. So there you have both spot and derivatives. I think GMX and Uniswap are good examples of that. Then you have credit and various use cases for credit, money markets, and then all types of leverage. And then you money management. I think the most interesting one is actually like Olympus DAO or the implementation of time, even though I know it wasn't done really well. But maybe like index fund as well, where people or now the
Uniswap v3 position rebalancing protocols like Gamma. I think that's also like wealth management or money management, and like we're naming these things so weirdly that we're losing track that these things already existed, I guess, and now we're just doing it better. And then everything else I think might be like super really speculative, like like a Facebook or an Uber. I think that's really speculative, but I think we'll probably see these financial applications play out with the stores of value. So people are going to want to take credit on their NFTs, and they're going to want to do that with Bitcoin and ETH, and then potentially some meme coin like Doge or Bonk. And then that's going to be like crypto maturing within its own sandbox. But then I think we're going to need to break out of our sandbox and go into real world assets. And I think we're already starting to see some of this. But yeah, I think if we can prove out that we can do instant settlement and have programmability and have an open permissionless environment for money with these like kind of like funny magic internet money coins that we're minting, then we can move all this value, like this technology, to like real world assets. And then I think that's hopefully how it matures. And there might be some permission chains or whatever that get tapped into as well asynchronously. But I mean that's my opinion. If we get stuck here in this like kind of like bubble of only playing around with the sandbox of crypto, it has a kind of like a cap, and the crossing over to real world assets, I think the use case has been proven by stable coins. Like those are essentially like derivatives, digital derivatives, or receipts of money that's stored in a bank vault somewhere. So I think that could probably be iterated on for a lot more assets.
So, okay, I guess we shouldn't get into the real world assets tar pit because that's such a deep discussion that I think it would kill the rest of this space. How about, okay, I guess one of the questions that I think we should go over is what was the essence of your partnership with Zellic?
Yeah, we have collected some questions from the community. Yeah, we're honestly, very happy to be working with y'all. You're highly recommended by other teams. I believe specifically the Aptos Foundation. Yeah, really great to be working with y'all. Y'all did a really good job with our audits, and yeah, excited to work with y'all. And hopefully continue building up Move and doing stuff like this where people can learn more about Move and Aptos and blockchain in general. So, but yeah, I guess what are some of your thoughts on our partnership and how we can work closely together?
Could you repeat the question? I just cut out for a second.
Oh yeah, just kind of curious to hear your thoughts as well on how you work closely together with us and maybe other projects and ecosystems like Aptos.
Yeah, we work closely with the Pontem team to audit both their DEX and their wallet. We just had a very good experience working with Pontem. They're extremely professional. In terms of working with other projects, I mean, I think that clearly what we do is we help blockchain projects stay secure. We're looking forward to helping prove out the Aptos ecosystem. It's really exciting space, and we want to make sure that everything is secure as it's being built out at this incredible pace. We want to be the people that are enabling the community to ship at this breakneck pace while also keeping their users safe. I think that's a very important job, and I'm glad to be the one who has to do it.
Nice. Yeah, this one looks also interesting. So, how can blockchain gain mass adoption when the users themselves need to have a high degree of knowledge of technical code to verify contracts, for example, to ensure safety when navigating Web3? So, yeah, given that it's so dangerous to navigate Web3, how can this gain mass adoption?
Well, I think we can compare it to the early days of the internet, right? Because initially it was just the tech enthusiasts and these like tech nerds who are interested in the internet, and people made fun of these nerds like, hey, like what are you doing on your computer all day, right? But as the industry matures, it's going to be available for mass adoption for everyday users, and that's going to come along with UX improvements, usability improvements, as well as better accessibility, right? Because a lot of America, for example, didn't have access to broadband internet until way into the 2010s, right? And that's still something that's being worked on the rest of the world as well. Now, I think one of the main issues that we face is that the UX of crypto is not easily portable or comparable to Web 2. So there's a lot of education that needs to be done. There's a lot of improvement that needs to be made there before we can see mass adoption. But I think that it's a very promising future for sure.
What do you see, I guess, as some of the guardrails that need to be put in place so someone like my grandma can come and start using crypto?
Well, I think the biggest problems would be custody, as well as phishing. That's a huge issue. We've seen fraudulent activity in CeFi. We've seen, what else are some issues? Well, we also need to just make sure that the markets themselves are safe because, for example, it's not great when a protocol gets hacked or a protocol has some economic issue that leads to some quote-unquote arbitrage, right? I think these are all things that need to be addressed. I still think that solving the custody issue and also social recovery is going to be very important. I think that's something that we're going to see in the next generation of wallets, perhaps. I'm not 100% sure on this issue because I'm just a humble security researcher who happens to have a company.
What do you think are some of the solutions for custody? Like maybe, so I've seen some that use like a threshold network, threshold cryptography network, I guess, to do like a giant multi-sig, and then maybe use like a social login as one event, and then your device is like another one. So that's one. But yeah, kind of curious to hear your thoughts on maybe what are some of the solutions to custody.
Well, regardless of what the solution is, I think the one danger that we always have to keep in mind is the trade-off between how nice the solution is versus how complicated it is, right? Because the fancier you make a solution, the more complicated it's going to be, and the more explanation you're going to have to do with your users, right? If we want grandma to be able to use crypto, it's going to have to be something that's pretty foolproof. And explain to her how social recovery works, what a threshold signature is, that's probably not gonna fly, right? It's got to be something that's very foolproof. I'm not 100% sure what the full solution is going to look like in the future.
Yeah, definitely agree. The user experience needs to be as simple as just clicking a few buttons, and that's it. I mean, I think even if it's super complex in the background, as long as the user interface is relatively simple and people understand what they actually need to do to stay safe, I think that'll be good.
I think it is very challenging because, I mean, one way that a lot of people think of their crypto right now is that they might have a hardware wallet or they might have a device with their keys on it, and that's essentially like keeping a big pile of cash under the mattress, right? And I'm not sure if grandma would be jumping at the opportunity of keeping her retirement savings as a pile of cash under the mattress, so to speak. I think she might want to deposit that somewhere. The question is, who would you trust to deposit that somewhere, right? It's a very difficult question. And I think that the solution to that is going to be huge, and looking forward to what we build.
Yeah, I think if maybe she grew up in the 1920s or in an emerging economy where their banks stopped giving out money, or stop withdrawals, potentially she might want to keep her money under the mattress. But 100%.
Oh yeah, yeah.
I think actually the centralized exchanges would be super useful here, as long as we don't give them full custody. Like I think shared custody with exchanges who also have the infrastructure for KYCML, which I think is also going to be important for this industry to really reach broad adoption. So I think what I envision maybe potentially is like, for example, a partnership with an exchange, and you just create a multi-sig with them, and maybe like one of them, one of the keys lives in your device, and maybe that's like safely stored on, for example, like the Samsung or Solana phone that has like a specific hardware storage for it that's well made, and something like that with in partnership with exchanges, I think might also help with this. At least people don't have to think too much about it, and they're not giving full control of their keys.
Yeah, I mean, you know what they always say, right? It's like not your keys, not your crypto.
Yeah, exactly. Maybe half your keys, half your crypto, or
yeah, who knows? I have no idea.
Cool. So, let's see what other questions we have. One that's interesting. How did you choose the name Zellic? And yeah, maybe.
Yeah, so Zellic stems from our background in vulnerability research, right? It's actually the name is derivative of Z-alloc, or like Z-allocate, which is a low-level memory allocator that's used in the BSD kernel and notably the macOS/XNU kernel, and that's because we were hacking some iPhones back in the day.
Nice. Okay. Interesting. What did you learn from hacking the iPhones? Are they like kind of like jailbreaking them?
Oh yeah, so like it's a long story, but I used to work in the VR industry where VR being vulnerable research, where we basically would originate, develop, weaponize, and sell exploits that compromise iPhones either remotely or locally, and then jailbreak them and proceed to do the full chain. I guess what I learned from that is if you throw enough money at any target, it's probably hackable.
Interesting. Would you say that's also true for something like an Ethereum or a Bitcoin or even like a Alt L1?
I mean, yeah, if you throw enough money at the network, you can just buy all the tokens.
That's true, yeah. But I guess the argument is that the price of it would go up so much that it would be very hard to get all the ETH required, I guess.
I mean, keep in mind that like if you take like I don't know Fidelity and you take like 1% of their AUM and use it to buy like Bitcoin, like you would buy like a pretty big chunk of all the Bitcoin in circulation.
You probably want to short it first. You probably want to manipulate the market down first, and then buy really cheap.
Oh, well, I mean, like this is not necessarily like an attacker who's interested in economic profit. This is just an attacker who is interested in harming the network, right?
Yeah, I guess my biggest concern with something like that is that if, let's say, we do start to trust critical infrastructure like banking on Ethereum, and a big state actor like China decides that we're not going to use that, that's not safe, but then they could theoretically have an attack on Ethereum, which it would if it took out like most of the Western economies' banking infrastructure. Like that would be pretty bad. So.
Oh, I mean, like I'm not gonna like make broad comments and stuff I don't understand, but like my vague feeling is that like all of our critical infrastructure is insecure anyways. So
yeah, that's true.
Mm-hmm.
it's just that like nobody fucks with it because they don't want to go to
Or
jail.
go to war, I guess.
Yeah, pretty much.
That's right. Yeah.
Because like if you like take over a power plant and then you cause like a computer to crash, like that's technically an act of war. So like don't do that.
Yeah, and unfortunately, that does seem to be happening somewhat more fairly frequently than normal. Like yeah, in like South
I mean,
Carolina.
yeah,
Yeah, it's interesting.
definitely not something good to be seeing. Yeah, it's not great.
Yeah. I wonder if Bitcoin has that same issue, I guess, because they have the ASIC miners. So you would need like really to bootstrap or buy a lot of these specialized hardware devices, which makes it a lot harder. And then so like even if you bought up all the Bitcoin, you couldn't hack Bitcoin because it's still proof.
I mean, like you just have to take over a few big mining networks because like there's a few points of failure. There's always centralized points of failure in every
You mean
system.
like one of the pools? Yeah.
I mean, like I'm pretty sure Bitcoin just has like maybe less than a dozen big pools, if I remember correctly, right? Ethereum's even worse.
Yeah, I guess the argument would be that the individual miners, if one of these big pools was hacked, wouldn't provide anymore. But and then you need to sustain that attack for a long enough period of time to like create a chain fork, I guess. And I mean, I definitely agree with the sentiment that if you throw enough money at something, you're probably going to be able to hack it. I'm just thinking maybe proof of work might be harder or be more expensive than proof of stake.
I have no idea. I mean, I still think that the tenet of if you apply enough violence to the problem and if you're willing to like get your hands dirty enough, you can like do whatever it is that you want to get done. So if like you're a government and you're just hell bent on doing something, like you're probably going to get it done. That being said, it might just be like really, really messy and people will like hear about it. But I mean, that's what I learned from hacking iPhones because it's like iPhones are these incredibly secure devices, but if you're just motivated enough to find the bugs and the market is willing to incentivize you enough to attack these devices, then you're going to find exploit chains in these devices.
So do you think maybe it's dangerous to move away from the App Store? Like I know in Europe they recently passed a law or there's some news about being able to sideload apps or creating.
Oh, I mean, like, I have opinions about this, but completely unrelated to security. It's just like a user experience thing. I think the upside of sideloading is that like I can put a DS emulator on my phone, which I think would be pretty sweet because then I can play Ace Attorney on the train, which I already do, but I just use one that's like a fucking website. It's just JavaScript. So go modern technology. I can have a website that's literally a DS emulator. And I can use it on my phone and play Ace Attorney on the train. So I think the upside of sideloading is that it obviously opens up the developer experience. Anyone can make and sideload apps. The downside, though, is that it like, okay, so imagine you go to like a restaurant and they're like, oh, to like see our menu, please sideload this app. Like, I would rather just fucking kill myself, to be honest.
Yeah, what kind of malware is this restaurant hosting?
Or not even malware. Like maybe their app is just like really shit, and then like it just sucks and it doesn't load or whatever, and then like maybe it doesn't support my version of iOS or something like that because there's no quality control, right? It's a sideloaded app, and or maybe like it's just like festered with ads or something like that. Or like imagine you go to work and you're on your first day of work at orientation, they're like, hey, like please sideload our company's app onto your phone, and I was like, I think I'd rather just kill myself.
Yeah, these walled gardens definitely create.
So there's an upside
Yeah.
and a downside. Yeah.
I think the biggest downside is that these app stores are kind of monopolies and they can set arbitrary rules.
Oh yeah, like don't they take like 30% of all in-app purchases? Like if you try to get Twitter Blue on your iPhone, it costs $11 a month. But if you get it on the website, it costs $8 a month. And I guess that's just like Twitter's way of just like protesting that like, hey, like Apple's fucking us. And they're just like passing it on to the consumer because they're like, we're not eating this. We're just gonna make the consumers aware that Apple's the bad
Yeah,
guy.
exactly. And one that's definitely kind of like price fixing because you can't have a competitor come in and try to offer better fees for an app store. Two, you also can set somewhat arbitrary rules like for example, NFTs were just a short period of time ago were like really difficult to get any NFT app. I think Coinbase posted about this also for iOS. Any form of crypto could also be easily quote unquote banned, and then really hard to get apps that are related to crypto on there. So it's almost like too much power and maybe being arbitrarily wielded is definitely not good either.
I mean, that's just like the way that tech stacks work, right? That's why, I mean, that's why investors, they love to invest into L1s, exchanges, bridges, and stuff like that, because that's where the value accrues, because those are the points of centralization. They're the fundamental building blocks that everything else has to be built on. In other words, you can rent seek.
Yeah, and that also seems to be like a strategy for tech companies, just like grow really quickly at pretty much zero profit or even negative profit, and then once you become a monopoly, then start to extract.
Well, I mean, we'll see if that strategy is actually good or not, because we've existed in a zero interest rate environment for the past 10 years, and now we're no longer in that. So now we have these companies who are forged on that principle, and now it's finally being put to the test, because it really wasn't being put to the test before. That's also why we've seen like multiples like just die. But I guess this is not necessarily the best space to be having a discussion about equity markets. Because also I'm not like an expert in like equities. I'm just like a humble security researcher who happens to
That's
have
okay.
a
It's
company.
fun to speculate. I think it's applicable here too. I think the somewhat VC, I guess, VC subsidized free rides and free food, similarly apply to crypto, where I guess VC subsidizes they had private sales of coins or tokens being given out for adoption of these protocols. I think also somewhat similar.
Yeah, it's CAC. It's customer acquisition cost. It's CAC. If something is free, then you're the product.
Yeah, exactly. But I don't know
Yeah.
if that applies here in crypto.
Hey man, all I'm gonna say is I really fucking miss when Uber rides were like $5.
I know, right?
I really
You
miss
get
that.
like $20.
No, but what you do is when one of the taxi apps gets expensive, there's always going to be like another taxi app that's like being funded by like someone, like an investor or something. So then what you do is you just stop using the old taxi app that ran out of CAC and is expensive now. So you switch to the new taxi app that's going to be slightly more buggy, but it's like way cheaper because they're getting hacked because they're trying to compete for the taxi market. It's great. So you just have to constantly jump between these apps and go to whichever one is cacking their customers the most right now. In fact, like you can like extract so much value from CAC if you're just like actively CAC farming your life. Like get those Instacart like credits or whatever,
I
right?
went through a phase of doing
I mean, if you think about it, it's actually like the world's worst form of universal basic income.
VC subsidized growth.
I mean, like, okay, this is a shit post, but like, what about like 30 years in the future when instead of like giving you free taxi apps rides or like giving you free food delivery, why don't they just like give you like a $100 check in your checking account every month, and then you just promise to like put your eyeballs on an app for 30 minutes a day and listen to propaganda? Like, that'd be pretty efficient, right? You can cut out the whole hassle of building a whole taxi company, right?
With CBDC, that could be possible.
Anyways, I'm just kidding. I'm just like, this is a joke. Like, don't take this seriously. I was just being like,
with CBDC tracking where you spend your money, I think it could be possible. VC subsidized basic income. I went through a phase where I did like pretty much all the meal kit companies where they just deliver like meal kits to you in the first month free. So like for half a year, I was just getting like highly subsidized free food.
Free food.
Well, it wasn't fully free, but it was
yeah.
I did that too exactly last term.
Oh my god, this guy's the humble CAC farmer. I gotta show you that meme after this space.
Yeah, sorry, Jazzy, you were saying.
Yeah.
And I was saying I did the exact same thing last term in college where I just got like 4 food delivery companies to give me food for like 3 months.
Yeah, exactly.
It's great.
Another one, the delivery services that do like snacks, like GoPuff. There's a bunch of them that also, where you could get like $200, $300 worth of snacks just for free from all these. Yeah, it's crazy. Cool. So I know we're running on time here. Any final thoughts? Any final words for the audience?
No.
Great.
No words.
We'll drop the mic there. Thank you guys for joining. This is a really fun conversation. It's awesome when we go off topic and talk about random stuff we're not experts in. So thank you for joining, and hope to have you again soon. And we'll love to